This question is about a unimodular complex number, students. What is the meaning of the word unimodular complex number? Is a complex number is said to be unimodular if the modulus of that particular complex number is 1. Is it okay? Modulus of that particular complex number is 1. The question is saying the complex number z is said to be unimodular if modulus of z is equal to 1. And it's also told in the problem that z1 minus 2z2 divided by 2 minus z1 divided by z2 bar is unimodular, which means modulus of z1 minus 2z2 divided by 2 minus z1 into z2 bar, this is equal to 1. So I can write modulus z1 minus 2z2, that is equal to modulus of 2 minus z1 z2 bar. Is it okay? So what we can do, I can say z1 minus 2z2 the whole square. When you square it, modulus is as good as not keeping the modulus. Answer is positive only. 2 minus z1 z2 bar the whole square, correct? So I can say z1 minus 2 z2 into z1. Now you see here. We also know that z into z bar for a unimodular complex number, when modulus of z is equal to 1, modulus of z bar also will be equal to 1. Z into z bar is equal to modulus z square, correct or not? For a unimodular complex number, z into z bar is as good as writing modulus of z the whole square. How? Let us say x plus iy is equal to 1. Then x minus iy also is equal to 1. X square plus y square if you multiply. Is it not? So I can write this as a same thing here. This is z into z bar I'll write. So z1 bar minus 2 z2 bar. Okay, I'll split it like this according to this concept, is equal to 2 minus z1 z2 bar into 2 minus z1 bar z2. Is it okay? z1 bar z2. It is as good as z into z bar, writing like this. So I can write z1 into z1 bar minus 2 times z1 into z2 bar minus 2 times z2 into z1 bar plus 4 times z2 into z2 bar, that is equal to 4 minus 2z2 into z1 bar minus 2z1 into z2 bar plus z1 bar into z2 bar, correct? z2 bar. Now z1 into z1 bar is nothing but modulus of z1 the whole square, modulus z1 square. Okay, minus 2 z1 z2 bar, this part and this part will get cancelled, this part and this part will get cancelled, plus 4 times modulus of z2 square, that is equal to 4 plus z1 square modulus into modulus of z2 square. Is it right? Yes. So we can write modulus z1 square minus 4 times modulus z1 square into modulus z2 square plus 4 times modulus z2 square minus 4, that is equal to 0. Modulus z1 square, if I take out common in these two terms, I'll be left with 1 minus here modulus z1 square minus, if I take out modulus z1 the whole square, I'll be left with 1 minus 4 times. So we have to group it properly. We'll group this like this. We'll group it in such a way that I can take out common terms easily. So I can write modulus of z1 square minus 4 plus 4 times modulus z2 square minus minus z1 square into z2 square modulus, that is equal to 0. So here nothing is common, 1 is common. Modulus z1 square minus 4 plus modulus z2 square is common into 4 minus modulus z1 square, that is equal to 0, correct? So here I can write 1 into modulus z1 square minus 4. I'll take out the minus sign common. Modulus of z2 square, modulus of z2 square into modulus z1 square minus 4, that is equal to 0, correct? 1 minus modulus z2 square into modulus of z1 square minus 4, that is equal to 0. So see, this part cannot contribute to making it 0, right? Since modulus z2 is not unimodular, see, z2 is not unimodular, is modulus of z2 is not equal to 1. Since modulus of z2 is not equal to 1, 1 minus modulus of z2 square cannot become equal to 0. This implies that modulus of z1 square minus 4 should be equal to 0. Modulus of z1 square should be equal to 0. Should be equal to 4. Should be equal to 4. So this implies to me that modulus z1 should be equal to 2, square root when you take. So root over x square plus y square, that is equal to 2. So x square plus y square is equal to 4. If you can see, compare this with the x minus 0 the whole square plus y minus 0 the whole square, that is equal to 2 square. Compare with the x minus h the whole square plus y minus k the whole square, that is equal to r square. So this implies to me that this is a circle with the center, 0, 0 and radius is equal to how many units? 2 units. Okay. Let z is equal to, let z1 is equal to x plus iy. So your modulus z1 will be equal to root of x square plus y square. This is easy to solve, easy to understand. Mark this question as important.